Hello and welcome to day 20 of our 30-day coding challenge from CS and Math. We've been wanting to do a variable progression day, and today is that day, something just focused mainly on variables and how to use them in mathematical problem solving. And we picked a would you rather task. These are, you could call them warm-ups. They were created by John Stevens. He's an educator from California. So in his Twitter, you see it's jstevens009. He has Would You Rather. He has a couple of books, Classroom Chef and Table Talk Math, which we also recommend. But he has these Would You Rather tasks that are very great to inspire student thinking and just outside the box problem solving. They are what we think are low floor, high ceiling, which we'll describe more in depth, and those are really good for programming tasks. So I'm going to just give you this scenario, let you pause the video, and think about how you might solve this. Now, certainly it's a good idea to have kids just make a guess. It kind of gets their skin in the game, you know what I mean? They get them kind of excited. Oh, I think I'd rather have this. It's going to be more money. Or whatever the would you rather task is, it's a 50-50 chance, right? So have them make what they think is the right prediction and then go in to validate or justify. Now, a lot of that should be done on paper, but sometimes in the computational process, once they've got a plan, executing it here with a program could make a lot of sense. So let's start with variables. What are things you might need? That's something I would have the kids list out, like I said, right on paper, or if they got their computer out, I suppose you could do it here first. Yeah, hopefully you said something about like what's the thickness, or some people might call it the width or something. I'm going to put coin thickness, put two S's on there, I guess. I'm just going to declare it to be 1. I can change that value here in a second. So coin thickness. Now, what I really also like about this one is, and I've ran this with middle schoolers a lot, and it was always very successful. They get into it to the top of your head. Now, your height, or whatever you want to call that variable can change, right? Some people are 6 feet tall. Some people are 5 feet tall, 4.5. Depends on what age of kids you're working with, but I'll just declare that at 1 as well, but we definitely want those two variables, right? And then kids have to go out and find them. So if they don't know their height, you could have some stations set up where they measure them. Let's do coin thickness. I had searched some of this before. So dimensions of a US quarter. So you can read through this, but essentially it says the width is 1.77. Excuse me, 1.75 millimeters. And so I'm going to set that. I like that number better because it's cleaner. So 1.75 millimeters. You don't have to do that. You certainly could do the inches, and then they could obviously measure themselves in inches easier. I'm just going to do a conversion for that piece. So then again, how much you want to do is up to you. Like, for example, the way I would have them do conversion here is just to search it. So I would say 6 feet to millimeters, which I already did. And they can feel okay doing this from what I wanted them to get out of the task. So whatever their dimensions are, or whatever their height is. So 1828.8, I'm going to keep that exact. So if I was 6 feet tall, I would have that particular variable declaration. Now, a good mathematical win for them might be to realize, okay, if I'm stacking up 10 of these coins, let's say that's going to be 17.5 thick, right? So that's going to actually give the total amount of coins. So if I typed in total coins, that's going to be equal to the height that I am divided by coin thickness. And then I'm just going to print that just to see what it looks like. Okay, now Here, again, you could say, well, this is a mathematical one, just realizing that the division would tell them how many coins they have. So just getting ways to think that through. You could be like, okay, well, let's do something easier just to test it. Or you could say, okay, what if instead of coins, you were stacking up rulers? You know what I mean? How many rulers? Just try to give them easy ideas so they can find success. So then, for example, I'm just testing out my basic calculation here to make sure it's functioning correctly. So I'm going to undo that. And I don't like personally that this is, I'm going to have to go over my height. So I want to round up. So I had searched on here how to round numbers in Python. It's something that kids can do, something that you can do. Excuse me, I'm a little off today. And then I would search, like I want to round up. So rounding up. And if I find down here, like to round up, oh, there's a ceiling function. Looks like it's in the math, import math package. So if it gives a few examples, oh, this one would take the ceiling of 5.2 and round it up to 6. Now, it might take them a minute to find that, but we found it. And usually when we import things, remember we want to do that at the top. So I'm going to import my math function. There's a ceiling here, so I'm actually going to do it on the total coins here. I would do math dot ceiling. Actually, it's just dot ceil, right? And parenthesis. And now this should round, if I've done that correctly, 1046. Now at this point you should probably say, well, now we know the number of coins, but what are we going to do with that? Well, we have to figure out what's the coin value. So I'm going to actually introduce this up here with the thickness. This coin value is 25 cents. I could put 0.25. So that would put that coin value in there, that coin thickness. Now if you're wondering why am I putting these in here instead of quarter, because I want to make it universal, like dynamic, something that we could change, right? A variable that could become an adapt to, let's say, dimes or nickels or pennies or whatever. So that's what I've kind of structured here. And kids might just do quarters, and that's perfectly fine. Again, there's no correct answer, which is one of the really nice things about this. So then what we want to do for our last calculation, we've already printed total coins, but we actually want to know the amount. So I don't know what you want to call that, but let's say in this string of variables, which was today's goal, the amount is actually going to be equal to the total number of coins times the coin value. And again, instead of this value, we're going to print the amount now. And so we've got the total coins calculated with that ceiling function. The amount that we're worth is actually equal to the total number of coins. If we have 1,046 coins in my case, each coin worth 25 cents. I can run that and see it's $261.50. And now they would have a way to justify. Again, they could try a few things to make sure it's working correctly. One thing I did when I ran these in classes, I actually had a bunch of quarters on the table. So then kids could actually go and measure like a stack of, let's say, 10 or 20 coins. And just something to verify and justify that what they're doing works. So there you go. There's a basic structure. Now, again, the concept of low floor, high ceiling is something like, okay, well, what if I wanted to challenge the kids to make your own would you rather scenario? Right, so let's say we challenge them to do that. I might say something like, what about dimes? Because they're thinner, maybe get that much more of them, right? So if I said dimes, now I just have to change my search to US dimes. Dimensions of US dime. Let's just go with this because I've done it before. It's 1.35, so not actually that much thinner, but 1.35. Now the value of the coin is only 10 cents. My height's still the same, and I could run this, and it only gets $135. So that one's not great. So let me pause and think of one that might be interesting. Okay, so in about 10 minutes here, I came up with, and again, this is what some kids that are really just finding it easy maybe would have time to extend this. Or maybe you make it a whole day instead of just a warm-up, and they could play with this and enjoy it. So you could even make it an assignment, I suppose, but I come up with make your weight in dimes or $3,000. It seems to me like my weight in dimes, excuse me, I'm having some struggles this morning, but your weight in dimes seems like a lot of stuff if you're heavy. So, for example, I'm 215 pounds. That's 3,440 ounces. Again, I'm not interested in the hand conversion here or things like that. So I made this scenario. Now I had to search different things like, okay, it's 0.08 ounces per dime, let's say, and I adapted my code to this. I changed from coin thickness to weight. I just adapted my formula over here to coin weight, my weight's in ounces, and the structure is fairly similar, right? And I run that, and it's actually 4,300 for me. So hopefully you found this interesting. Hopefully you found something that you could take away and use in your own classrooms. Hit that like button, hit that subscribe button, and we'll see you next time. Thanks for watching.